Welcome to lecture series 8051 Microcontroller. In today's session, we will discuss about how to interface the stepper motor with the 8051. Already we have discussed what are the features, what are the special functions in 8051. So, for that it has a 4 ports for peripheral interfacing, port 0, port 1, port 2 and port 3. Okay. So, based on these 4 ports can be used as a IO ports, either a 32, each port having 8 signals. So, totally 32 signals you can use it as a input ports, or 32 signals can be used as a output ports. Okay. So, not only with the IO signals, it also multiplexed with the address and data lines or some peripheral functions like interrupts or timers, okay. Then serial communications. So, now how these ports are used to interfacing, that way only we have started to discuss. Okay. Then where with what device we are going to interface means with a stepper motor. So, already we are strong in 8051, now we have to know the function of stepper motor. Once you understand the function of stepper motor, then we can easily make the physical connection interfacing, then we have to activate the corresponding coding. So, what is stepper motor? Stepper motor is one of the DC motor which is used for performing the step by step movements. Mostly it is used for the position controlling. A stepper motor, it converts the electrical pulses into the mechanical movement, that is electrical signal into the mechanical action. So, due to this mechanical action, okay, by giving the electrical signal, the motor is started to move the knob which is used for holding the particular position. It gives the step by step movement. It widely used for the position control in printer, especially in dot matrix printer, disk drives and robotics. In case of dot matrix printer, right, so here we have to hold the two position, one is for holding the paper, another one for holding the header. Okay. The header, what it will do, from the leftmost position it will started to move. Okay. So, from this position it will type the character, then it will jump. Suppose you want to type the character the, means first it will type T, then it will move one step, then H, then it will move one position, then E. So, for the step by step movements, the header is controlled by using the stepper motor. So, here the stepper motor is connected. So, within that it will step by step movements. The same thing in the paper, what we are doing, first one line is typed, then only we are started to type the second line. So, by this, okay, the line control, which is after typing the first line, it will move one position, it will give the next empty space for typing the next line. So, one stepper motor is used for paper control for line feeding, another one for header control. So, two stepper motor is used in the dot matrix printer. The another one you can take it as a disk drive, either the hard disk or CD drive. Okay. So, the disk is 360-degree rotation by using the servo motor, it is a constant speed, but the disks are separated with the number of tracks and sectors. The head movement to read the header from the sector and track, the header is very important. So, this is a header position which is used for the inner round or outer track, or so the sector, each movements will be identified or read by the header, which is controlled by the stepper motor. Okay. So, in the disk drive, stepper motor is used to read the tracks. The another one is robotics. The robotics arms, mostly nowadays we all are realizing the robotic applications in our day-to-day lives. Okay. How the robo movements are mostly in the step by step movements. So, in the step by step movements, how it was picking the object or how it identifying the locations, okay, the arm positions and the finger controls, everything will be performed by the stepper motor. So, stepper motor is one of the DC motor playing main roles or many small applications. So, these stepper motors having the two types, one is a permanent magnet stepper motor, another one is variable reluctance stepper motor. So, based on its structure, we are giving the name as permanent magnet stepper and variable reluctance. Permanent magnet stepper motor means here usually the motors consist of the rotor and stator. So, rotor is a rotating part, stator is a stationary part. Okay. So, here how we are applying the function means the rotor is made up of the magnet, the stators are connected with the electrical supply. So, once you started to give the supply for the stator, then it will energized due to the energization because of the magnet. Between these two no connection, but the EMF is introduced. Because of the EMF, electromagnetic force, now the rotor started to rotate. Okay, this is a motor operation. So, for that the permanent magnet stator, the rotor which is a permanent magnet is used to design the rotor which is surrounded by the stator parts. The permanent magnet motors use the permanent magnet in the rotor and operate on the attraction of repulsions between the rotor permanent magnet and the stator electromagnets. So, due to the electromagnetic force, the rotor is rotated. Okay. The another one is, and one more thing in the permanent magnet motor is, the rotor is teethless, there is no teeth in the rotor part. The variable reluctance stepper motor, the variable reluctance motor have a plain iron rotor. There we are using the magnet rotor, here iron rotor, and the operation is based on the principle that minimum reluctance is occurred with the minimum gap, hence the rotor points are attracted toward the stator magnet poles. The variable reluctance stepper motor has a toothed non-magnet soft iron motor. Okay, either this way or this way you can call it as, but here the rotor is some tooths. When the stator coils is energized, the rotor moves to have a minimum gap between the stator and its teeth. So, by the diagram you get the idea. This is a permanent magnet stepper motor, which the rotor parts is a magnet which have a north and south poles. The stator parts are coiled. So, whenever you are applying the electric charge, this will be energized. Okay. Due to the energization, electrical signal, here magnetic signal, due to this interaction it started to rotate. So, how it started means same poles will repel to each other, the opposite poles are attractive. With the concept it will be started to rotate. So, this rotation will be step by step, because these four status within this, first here attractive, then here this way it was rotating. So, the rotation may be either in the clockwise direction or it will be in the anti-clockwise direction. The another one is variable reluctance stepper motor. So, what here only we are using the iron with the teeth end. Okay. So, some teeths are projected with this is a rotor part, then the stationary parts are coiled to supply the electrical signal. Now, we will discuss the step operation, how the stepper motor will give the step operations. Basically, it have a two kind of mode of operations, either full mode operation or half mode operation. Full mode operation means at the same time two stationary parts will be connected. Okay, that is the stator parts. So, two stators are energized at the time, that is the full mode. In half mode means only one is energized at the time. For full mode, it need the 4 step of sequence. Suppose the coil, we have a 4 coils, right. I will give it the name, it as A, right, B, C, D. So, only one of the signal, suppose here both are 1 means, okay, these two are 0. Here how the coils are connected means A and B both are commonly connected, that is the unipolar. Okay. These two C and D are commonly connected, AB and CD both are commonly connected. If any one of the coil is energized, then automatically it started to rotation. So, this way suppose if I am giving ABC, so first A and D should be 1, at the time B and C are 0. Okay. There is no electric signal applied for B and C stator, applied for A and D. So, this is the initialization value you can consider, this is a step 1. Then after that, suppose I am rotating in the right direction means what will happen, 1 1 0 0. This is second step. Then in the third step 0 is inserted, 1 1 0, then 0 0 1 1, then the same thing is repeated. So, you leave it. So, only 4 steps are required to energize the 4 stator coils. So, due to this energization, the center part rotor is started to rotating. So, here only 4 steps are required, this is a full mode of operation. In case of half mode of operation, only one is energized at a time, the same 4 stator parts we are taking. So, 1 0 0 1. In the step 1 we have initialized, right. Another one how we are doing means only one part is energized at that time. So, now D is deactivated, that is we are of the power to D now applied to A, then it shifted to A B 0 0. Now, A and B both are energized, A already energized, now it given to the B, right. After shifting the signal now it become 0 1 0 0. So, now we are remove the power to A and continuing only B. Okay. Now, we are applying the signal to B and C. So, 0 1 1 0. Then we are giving the signal only for C removing by B. So, 0 0 1 0, right. So, after that we are giving the power to D. So, 0 0 1 1. Okay. So, now we are shifting 1 0 0 1. So, totally how many steps is needed for this means this is a 4 step. We are continuing the charge on the D. Okay. So, by this you can get understanding only one coil is energized at a time, right. So, first of the condition to D, then A is continued, then B is on, then removing A, then B to C, then continues C, then remove the B, then it passed to the D. Okay. So, this way we are doing the operation, that is why it call it as a half mode operation. So, to complete this it need the 8 steps, either you can say it is a 8 step sequence or half mode operation. So, by this we are activating. Now, I started to write the program. So, how we are starting to write the program means this initial value only we have to load it. Okay. Suppose if you want to activate this means I want to set this bit position, then clear, clear, set. So, how I have made the connection. So, based on that, suppose I connected with the port 2.0, port 2.1, port 2.2 and port 2.3. So, these 4 signals are connected with this or 4 coils. So, how I will write the program means set bit, right, port 2.0, then clear bit port 2.1. For C which is connected in the port 2.2, so clear port 2.2. Okay. The last one is D signal which is connected with the port 2.3 as 1. So, set bit port 2.3. Okay. So, by giving these 4 instructions, these 4 coils are activated, right. Then we have to rotate the positions. Once the initial value is initialized, then you can simply giving the rotate operation we can complete it. But this is a 8-bit processor. So, how we are loading, that is important. So, here if you are loading 99, either you can load the 99 or you can load this value CC, or you can load the 66 or you can load the 33. So, any one of the values you can load it and do the rotations, automatically it will comes. So, here how we are identifying number of steps. Number of steps identified, this is a one complete circle which is a 360 degree divided by the step angle, right. So, suppose you want to give a 4 step of operation means, so what is the step angle? So, step angle is equal to step angle theta equal to 360 by 4 step. In the 4 step means you get the 90 degree shift, right. Initially the motor is here, then it comes to here, then comes to here, then it comes to here. This is a 4 step, okay, 90 degree movements. In case of if you are taking the 8 step means how it comes, 360 divided by 8. So, which will gives us 45 degree, right. So, it will gives the step movements like, so initially here, then here, then here. So, 8 jumps it will give it, right. So, this is a 145, 0 to 45. Either in case of clockwise direction means it started, suppose your starting position is here means, then here to 45, then next to 45, then next to 45, next to 45. So, this is the way it will rotate, okay. This is a clockwise rotation. the reverse direction is anti-clockwise direction. Okay. Suppose simply if you want to interface stepper motor with 8051, now how you will write the program means, first you have to initialize the starting value, move a comma the given number either 33 cc, here I am take it as a 66. Okay. Then after that what I have to do, in case of clockwise direction you have to rotate the data. If you want to rotate the motor in the clockwise direction means you have to rotate in the right direction. So, the given data value is rotated. So, initially the value is, you consider only a single bit 0 1 1 0, right. After rotating it become 0 0 1 1. Okay. You consider A, B, C, D, the corresponding coils will be energized. The same process you can repeat it. Okay. So, how we are repeating means a number of times you can repeat it. So, simply you can give it as a short jump. So, move accumulator comma the data rotating, then where the motor is connected you have to give the data. So, move P2 comma accumulator. So, the accumulator value is now it passed to the port 2, which is port 2.0 to port 2.3. So, based on this now the signals 1s and 0s will be passed, the coils will be energized, then the motor will rotate. The same process you can repeat till your condition meet, or continuously you can give the rotation. Suppose you want to give only 10 steps or 40 steps means, here you can give the value move R0 comma 30 H. Okay. If you know the counts then you give it, here you can give it decrease jump not equal to 0 R0 comma here either here to here. Okay. So, this kind of rotation also you can perform it, at the end you can end or short jump. So, initialize the starting value, right, then you started to rotation. The same thing, suppose you want to rotate in the left direction means anti-clockwise direction means, no need to write the another program, just you replace this rotating right by rotating left. So, rotating left accumulator means what will happen, this bit positions, this is the initial value, right. Now, it become 1 1 0 0, right. Then next it become 1 0 0 1. So, this left direction is rotated, which will gives the motor to rotate in the anti-clockwise direction. The right direction rotation which will give the clockwise rotation. So, how the stepper motor is interfaced? Microcontroller, right. So, here is the 8051 microcontroller. So, I have connected the port 2. So, port 2 have a 8 signals, but I used only the 4 signal. So, these 4 signals. Okay. So, here already we know this is a rotor, then it was connected with the 4 coils, right. So, the 4 coils you can give it as A, B, C, D, right. So, here how you are, either you can directly connect or you can connect it with the some transistor, okay. Some base resistance with the transistor you can connect it, or simply you can give as a one of the amplifier . Okay. So, the device which will support, usually we are using the transistor to limit the current, okay, to avoid the device damage. So, for that we are allowing the current passing via the resistance and amplifier, right, which is to adjusting the voltage, stepper motor voltage to the controller voltage. Now, this PA naught is connected to the stepper motor, right. Then B is connected with this, then C is connected with this, then D is connected with this. So, 4 coils, right? Okay. So, these are coiled. So, whenever it energized automatically because of EMF, okay, the rotor will started to rotate. So, this is a physical connection interfacing between the microcontroller and stepper motor. Okay. So, now whether you want to rotate the motor in the clockwise direction or in the reverse direction. So, in clockwise direction means the initial value, suppose I initialize the value 0 1 1 0, either you can give this value or 1 0 0 1, any value you can give it, right. So, by giving this value the motor will started, suppose you want to rotate the motor in the clockwise direction means you have to use the right direction rotation. Okay. In case of left direction means rotating in anti-clockwise means you can use the rotate left instruction. Okay. So, by this way you can rotate the motor either in the left direction or in the right direction. At the same time you can control the step size also. So, how much of step size you want to move it, because the motor will rotate step by step, because we have a 360 degree, among the 360 degree how much of angle you want to rotate, either 10 degree or 15 degree, 45 degree, whatever you want you can give it. Suppose I am asking you to rotate the motor in the full step clockwise direction with the angle of 64 degree. Okay. Suppose I am asking you to rotate in the 64 degree means here I am considering one step equal to 2 degree, one step equal to 2 degree. So, then 4 step means, because this is a full step which consists of 4 steps. So, it will give a 8 degree. Okay. So, by giving a single rotation it will give the 8 degree. Now, I need a 64 degree. So, 64 is a 4 times of 8. Okay. So, this 4 steps should be repeated 8 times. By repeating of 8 times only you are getting. So, totally it need a 32 steps. So, totally 32 steps needed to give a 64 degree angle. So, for that how I will write the program means, initially how we are doing, move a comma the given value which is 66. Okay. Then you know the steps, number of steps. So, you can initialize in any one of the register. Suppose if you are initializing the register in R1 comma 32H. Okay. Then you can use rotate, which direction I am asking, how to rotate in the clockwise. So, rotate right accumulator. So, after rotating the data, the motor is connected in the port 2. The motor is connected to the port 2 of 8051. So, you have to move to port 2 comma accumulator. So, what it represents, the available value of the accumulator now move to the port 2. Based on that the ones and zeros will be activated, the corresponding coils will be energized. Then you can give a small call, that is a delay, this is the absolute delay. So, by making the delay you can understand the step size. So, you can initialize the delay if you want here, then repeat the process till reach the 0 value of R1, then again it will started to rotate. Okay. So, this way only we are moving. So, for the delay you can initialize any one of the maximum value. For delay program you can initialize move R2 comma FFH, right. Then decrease not equal to 0 of R2 till you continue the process. Then you have to give the return instruction, which is very important to return back to the main program. Okay. So, if you know the degree or step size whatever you want, you can calculate it, that will be initialized here. Then based on the clockwise direction you select either left or right. In today's session we have discussed how to interface the stepper motor with the 8051 microcontroller. It is a 8-bit microcontroller. Okay. The stepper motor will be rotated either in the clockwise direction or anti-clockwise direction. then how many steps you want to move it, either in the full mode of operation or a half mode of operation. Okay. So, after calculating that, number of steps will be initialized in any one of the counter or register, then which port is connected with the microcontroller, then after initializing the initial value, that will be moved to that port, then the corresponding coils are energized, then the rotor will rotate because of the electromagnetic force. So, this way we have discussed on today's session. I hope now you can write the program to rotate the motor in any one of the direction. Okay. Hope you feel understand, and thank you.